Okay. Shut up. Shut up. Hello, shut up. Is this thing working? Quiet, please. Hello. Okay. We're okay. Hello again. Welcome to week 3. We're going to be picking up the pace from here, and you know I've been taking it a bit slow, going over stuff so far. Do you think that? But we have a lot of stuff to cover, and we're already getting a little bit behind. So things are going to get a little bit faster, which means go to your labs, because I know a number of the labs are not full. A lot of the people are not turning up to their labs. Please do go to your labs, because that will be the occasion we have more chance to experiment with the things that I'm talking about and to ask questions of your tutor. I will also be working on setting up consultation times this week. But the thing to notice is, of course, that if you're in COMP1400, you should be talking to me. If you're in Infosys 1609, Infosys 609, you should be talking to Claude. And once again, I say the Infosys. So, if you're not on the air. All right, I will try running it again. Desktop presenter. Yes. Okay. So once again, a couple of people have been asking me about Blackboard. We are not using Blackboard for this subject. Everything will be either on the COMP1400 blog if you're COMP1400, or the Infosys 1609 blog if you're Infosys 1609. Again, the blog, that's the URL for the blog, blogs.unsw, COMP1400, or blogs.unsw, Infosys, wherever that one is. There's the Infosys blog. Now, the most important thing to look at on the blogs is that the first assignment is being drafted, shall we say. It's not quite out. The details for the first assignment there for Infosys on that blog, and on the COMP1400 blog, there's details for the COMP1400 assignment, which will be finished later today, because I've only just started doing it. Shut up! Right. So the important thing is they are different assignments, and you do not get to choose. If you're in Infosys, you do the Infosys assignment, and if you're in COMP1400, do the COMP1400 assignment, please. So please make sure that you're doing the right thing. It will say quite clearly the red one is COMP1400, the blue one is Infosys, but I'm not going to go through them both today because we don't really have time, or either of them today because we don't really have time. But do keep an eye on this. This will be finished up later today. Hopefully both of them will be finished later today. And do come. I will publish consultation hours on my blog, and hopefully Claude will publish consultation hours on his blog. If you have any questions about the assignment, talk to your tutor, come to a consultation. But lectures, we're going to be steaming right ahead, because we've got to cover some of the material that you'll need to use in your assignment. So, plowing right into it. We're going to be talking about local variables and conditionals and a couple other bits and pieces in order to clear up what we're doing. So we talked a lot about variables, and we talked about how fields are variables and how parameters are variables. And now from now on, I'm just going to be talking about variables in general, and I'm going to be referring to all of these different kinds, unless I specifically talk about fields or parameters, or I'm going to get into local variables now. I'm going to mean all of them. Sorry, I have my throat is going. One of the important things about variables is that every variable has a fixed lifetime. So a variable is a box for storing a piece of information, but it only has a fixed lifetime. It's only around for as long as you need it, essentially. And this lifetime is what we call its scope. And so a field variable exists as long as the object that it's on exists, the object that it's part of exists. So a field variable can exist for a long time, right, essentially. A parameter variable, on the other hand, only exists in that method. And when the method finishes, that variable is thrown away. So if you have a parameter on a method, and you provided a value when you call the method, that value only exists as long as you're in that method, and when you return from that method, that value goes away. And it's forgotten, and next time you call the method, you'll give it a new value for the next time you do it. So this is the idea of scope, that a variable only exists within a certain scope, and when that scope runs out, the variable is forgotten. So we're going to now come across what we call a local variable. A local variable is a variable whose scope is only one method. It's declared in that method, it is used in that method, and then it is thrown away at the end of the method. So local variables, whereas fields are used for storing information that's going to persist over time. So for example, we have a field in the ticket machine for how much money you've collected so far, and that's information we want to keep over time. A local variable is only for temporary space for doing calculations. So sometimes you need a bit of scrap space in which to store values that you're working on, and then you don't want to store them in the long run. Once you've finished doing your working, you can throw them away. So a local variable is an idea of temporary space for storing information. A local variable should always be initialized, and I'll show you what we mean. So the definition, the syntax is very similar to every other variable declaration that we've done before, but in this case, a local variable is defined within a method. So we have some method here. We just called the method, which isn't really a good name for a method, but it'll do for this case. And inside the method, we have this variable declaration. Like every other variable declaration, it has a type and a variable name. Unlike fields, it doesn't have an access modifier. There is no sense in having access modifier because this variable is only accessible within this method. So local variables are local. They're only accessible within the method that they're defined in. So the other thing that a local variable declaration always should have an initial value. So when you define the local variable, you also have to say equals and then some initial value. Unlike method, where we said before that fields, if you don't initialize them, they're automatically set to 0 or some sort of 0-like value. Local variables, you must always initialize them to whatever value you want, whatever starting value you want. So let me show you how we'd use this in our code. So let's go back to the ticket machine. I've written a fair bit more of the ticket machine in between times, but we wanted to do a refund method. So let's go down and look at that. So here's our refund method. Now, let's just I'll just cut that out for a second. So this refund method, we said it refunds the current balance. So it sets the balance to 0, but it also returns whatever the amount is that it's going to refund. So it's kind of an accessor method and a mutator method at the same time. It gives you the balance, it tells you what the current balance is, and it then resets that balance to 0. Now, if we were just writing the method to return the balance, it would be easy. We could just say return balance, right? And we talked about how the return statement sets the value that you're going to return. And so this would work fine. It would return the balance, but it wouldn't change the balance to 0. Okay. So the obvious thing now is to say return balance equals 0, right? Which you would hope would return the balance value and then set the balance value to 0, which is what we want to do. This won't work. And in fact, if we try to compile this, it should give us an error. Unreachable statement, it says. Remember I said last week, a return statement is always the last thing in your method. If your program hits a return statement, I'm tangled. If your program hits a return statement, the method hits a return statement, it will stop and return, right? And so if you ran this, it would return balance and then ignore this. It would just leave at this point. And so this code would never get run. So this is a problem because we can't return the balance and then set the balance to 0. We have to, but if we do it in the other order, if we set the balance to 0 and then return the balance, then we're always going to return 0, right? Because we're throwing away the old balance information, we're overwriting it with 0, and then we're returning that value, and so we're returning 0. That isn't going to do what we want either. Right? So what we need is some temporary space in order to keep track of, to hold on to the balance for a second while we clear it. So what we're going to do is define a temporary value here, refund and we'll initialize it to the current balance. What we do now is we've created, on the fly, we've created a little bit of space in which to remember the value of balance. And so we're copying balance into the refund variable. We're then setting the balance to 0, but the old value is still hanging around in this variable refund. And so now we can return the value of refund, refund if I can spell, and that will do what we want. So in terms of drawing boxes on the board, we had a box marked balance. It maybe had 100 in it. It was an int, right? If we just set that to 0 and return it, we're going to be deleting that 100, setting it to 0, and then returning the value 0. That isn't going to do what we want. So we need to create another box here, refund. Now, and we initialize that value to be equal to balance. And so we copy the 100 from there into there. Then we can freely throw away that value. And then we can return this value, and that's the return value is 100, right? And then once we've returned from this method, this refund gets thrown away because it's only we're outside of the scope, and so that variable gets thrown away, and all we have left is the balance field, which is a field, and so it hangs around. So local variables are just temporary space for moving data around, and sometimes for calculations. So in this case, it was just somewhere we could copy down the value temporarily while we cleared the other thing, and then we could return the thing we wanted, the thing we were holding on to. So it's really useful well, you're going to be using local variables a lot. They're just a way of temporarily holding on to data while you're doing something. Often it's useful, even when you're just doing a rather complicated calculation, is rather than doing it all in one hit, you could break it down into several different lines, store them in different variables, and then throw them away at the end of the thing. It's like, sorry, my voice really is going funny. This is great. Look forward to later in the week. So like any other kind of variable, give them sensible names. And make sure, and they have a name, they have a type, they are initialized, but otherwise they're like any other variable. And you can use them in the same way as you can use any other variable in your code. What was I going to say next? Let's go back to the slides. That's where Okay, so this is the scope. The scope of this variable is everything that's within, from here, from the declaration down to the end of the method. When we're outside the end of the method, that variable no longer exists. What this also means is that we can have another method over here. I don't know what we're going to call it. Something. Do something. Let's just whatever. Whoops, back to front. And this method can also have a variable called refund. Right? And the scope of this variable is this method, the scope of this variable is this method. They have the same name, but they're completely independent because they have completely separate scopes. So you can reuse, whereas you couldn't make a value, well, it would be a bad thing to make another variable here called balance because there's already a variable called balance in that scope. But because this variable only exists until the end of this method, we can have another variable with the same name within a different method. So local variables often, you often have the same variable used in many places, or the same name used in many places to denote a different local variable because they all have separate scopes. Okay, so we've encountered three kinds of variables. And all three kinds of variables work in very much the same way. They're all used to store data. They all have a type to tell you what kind of data that is. And they all have a fixed lifetime or a scope. But fields are one kind of variable. Fields are defined outside of methods. So they're in the body of the class, but they're outside the methods. Usually you put them at the top of the class, but you can put them anywhere you want. I wouldn't I would always put them at the top of the class to make your code readable. Fields are initialized in the constructor. So when you construct a new object, you initialize those fields, and you always initialize all the fields. It's just good style to always initialize all the fields, even if they're going to be 0. And fields exist until their object is destroyed. And we'll talk a little bit later about how you destroy objects. Mostly in Java, just objects get destroyed when automatically when you're no longer using them. But that means those fields hang around for a long time. And therefore they're used for storing state, because state is the kind of thing you want to hang on to for a long time. Parameters are also a kind of variable. They're defined in the method header, in the parentheses in the method header. They're also initialized by the caller. So when you call a method, you initialize its parameters, and they exist until the method ends. And so they're like local variables. Their scope is only for that method, and then once the method is over, the parameters are thrown away until the next time you call the method. Local variables are defined in a method body, so they're actually inside the method with the code of the method. They're initialized when they are defined, and you must initialize them when you create them, and they exist until the method ends. So like a parameter, that variable only exists until the method ends. In fact, local variables can be one step even more local than that. Local variables can exist only within a block, and we'll get to see what that means in a second. But local variables can exist within just one subpart of a method if you want. I don't know why I pressed that. Let's keep going. Okay, so that's what. So then, the next thing that we wanted to do. Next thing we wanted to do is make the purchase ticket method. So this is the last thing we're going to do in our ticket machine. The purchase ticket method. So let's do again. Let's remove that. I'll cut that, and we'll talk about it. Build it first, and then oops. Oh damn. Cut. The other thing you'll notice is that I'm breaking the style rules. I should keep doing this. My personal style for methods is like this, where this brace goes up there. That's not the style that we're recommending you use, so I should use the style that we keep telling you to use rather than the style that I prefer. So like that. That's much prettier. Okay. So when we want to buy a ticket, so we've got all this, we've collected the money, and now we want to actually buy a ticket. So we need a method in order to do that. So we're going to have the purchase ticket method. It's going to be, for the moment, we're going to make it a mutator method. So it's not going to return anything. So it's a void. It's a public method because we want to be able to use it from outside the object. It's void, which means that we're not going to return anything. We've got a decent name for it. And what we're going to do is provide a single parameter, and this time the parameter is going to be a string. So we want to provide a destination for where the ticket's going to go to, and so we're going to provide a string for that ticket, the name of the location we're going to. We're not actually going to pay attention to that string, but we're going to just pass it in so that we can put the name on the ticket. So what does the purchase ticket method do? Well, fundamentally, the purchase ticket method checks the balance, sees if there's enough, if they've inserted enough money. So if there's enough money for the ticket price, subtract that money from the ticket price, and then issue the ticket. Right? So first thing we need to do is to actually test whether or not they've given us enough money. If we haven't got enough money, then we need to give them a message that says that they haven't given us enough money and not give them a ticket. If they have given us enough money, then we have to give out the ticket. So this is the first example of more structured code that you'll see. Great. So far I've said that a program is a list of instructions, and you start at the top and you execute those instructions in order. But obviously, sometimes you're going to need to do things that are out of order. And one of the things you're going to need to do is to actually test something and decide and make a decision. And in this case, what we want to test is whether or not there's enough money. So let's actually put a comment here. Check if the balance covers the ticket price. I don't know if you can actually read that. They make the comments grey for some reason. Okay, so in order to test whether the balance covers the ticket price, we need to use what's called the conditional statement or the if statement. This says if balance is greater than or equal to ticket price, okay, so now what this statement does is this thing in the round parenthesis, this is a condition, and it says if this condition is true, then do what's inside the braces, inside the body of the if statement. And then we can optionally have another part here, which is the else part, which is what we do if it's not true. Okay. So at this point we branch our code. If it's true, we check a condition. If it's true, we do one thing. If it's not true, we do another thing. Now, if it's true that the balance, there is enough balance to cover the ticket price. So if the balance field is greater than or equal to the ticket price field, then we can buy a ticket. So what do we do when we're buying a ticket? Well, first thing we do is we subtract the ticket price from the balance. So balance equals balance minus ticket price. So that way we've actually spent some of the balance. The next thing we do is actually issue the ticket, right? So in this case, all we're going to do is we're going to print out a ticket on the console. So let me show you what that looks like. I'm just going to say system.out.println. This is rather messy and we're not going to explain exactly what that means, but ticket, let's just do something like this, pretty ticket and let's put another line in there, destination, and let's add the destination here, plus destination. Okay, so all that's going to do for all this horrible looking lather, all this is going to do is print on the screen the words ticket and destination with the destination. I'll explain that in more detail in a second. If there isn't enough balance, then we have to do something else. We have to give them a message that tells them that they haven't got enough balance. So let's do that. Oops, wrong one. So error, insufficient balance. And it's always a good idea to, when you have an error, tell them as much detail as possible. So we'll actually tell them what the balance is. There we go. And let's put another set of stars here in order to make it look important. There we go. Okay, so let's try that now and see what it actually does. See first of all whether we can compile. Okay, that's wrong. Okay, I've used the word ticket price here where it should be price, and therefore that one should also be price. Let's compile that. And again, I've spelt balance wrong. And okay, it compiled. Good. Okay, so now if we grab our ticket machine, we'll make a new ticket machine. We'll give it a ticket price of 100. And there's our ticket machine. Now, let's try to purchase a ticket. Let's purchase a ticket to whoever. Let's purchase a ticket to Ashfield for no particular reason. And there we go, insufficient balance. So the message we just wrote, there it is printed out, error, insufficient balance, and it's 0, which is the current balance. Okay. So let's try adding some money to the machine and seeing whether we can actually, let's add 150 to the machine. Now if we try that same method, purchase ticket to Ashfield, there it gives us, it prints out our ticket with the destination Ashfield, and hopefully if we go and inspect the state of the machine now, our balance is now at 50. So what it did is what we wanted it to. It subtracted 100 from the balance, it printed out the ticket. In the other case, it didn't actually print, it it said that there was insufficient balance to do it. If we try to buy another ticket, wherever, it'll say there's insufficient balance. The balance is currently 50, but the ticket price is 100, so it can't give us a ticket. If we actually want to have a look at that in action, we can use the debugger. We can put a breakpoint here at the beginning of the conditional statement. Oh, good, we've got plenty of time, and we'll run that. Whoops. And so now if we run purchase ticket, and here somewhere, okay, so now the debugger comes up at this line, it's stopped at the breakpoint, and now we can step through. So we can see over here the instance variables that we have. So these are the fields, the price is 100, the balance is 50. We also can see the local variables. So in this case, the parameters are included under the local variables, and so the destination is a parameter. It's a variable that only has scope in this method, so it comes in under there. And now we can step through the method. It compares balance, tests whether balance is equal to, greater than or equal to price. We step forwards. Now the test failed, so the test was false, and so it jumped down to this else part of our code, and now it runs this line of our code, which prints out the insufficient balance message. Okay, and now if we keep stepping through, it finishes the method, and it's all over. But if we go back and run that again, let's put some more balance in our machine, put some more money in here. Let's put another 300 in there. Okay, and now we purchase a ticket to there, because I've always wanted to go there. Now we're running again. This time the price is 100, but the balance is 350, and so the balance should be greater than the price, and so it chooses the first option. So if balance is greater than or equal to price is true, and so it starts running the first piece of the code. The first thing it does is take the price off the balance, so the balance is now 250. The next thing it does is print out those two lines of the ticket. So that's the conditional statement. We use it in our code when we want to make choices based on the data that we have. Okay. So a conditional statement looks like this. If condition, then do what's in the first set of braces, else do what's in the second set of braces. Either way, whichever one you run, it continues down here. So if it does the first set of braces, it will run the line in that set of braces, and then it will continue down there. If it does the second, it will jump to the second set and then continue down there. All right. So, and a couple of things to note. The if statement, the condition is in round parentheses, and the two bodies, the true part and the false part, are in curly braces. And the standard style that they recommend for this is to actually put this on the same line as the if and the else. Go figure. We're going to follow what they say, so that's going to be our style. So we use a conditional statement in order to perform tests and branch based on the results. So we check if something's true about our data, our state, and if it is true, we do one thing, and if it's not true, we do another thing. Sometimes it's pretty common actually that the else part is empty, where we just say if this is true, do something, otherwise don't do it. In which case you can leave the else part off and just say if condition, do this, and otherwise it'll just ignore everything and continue here. So that's an easy way of if there's only one side of the test that you're interested in, then you can just say if condition, then something. All right. So given that we have a bit of time, I'm going to actually show you, draw something. Hopefully you can. Is there a way to turn on the lights here? Lights. Lights, 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 lights. Oh, board lights. There we go. Let's see what that does. Vaguely. Okay, so a useful way in designing your code is to think about these things. Is before you go out and try and write all this directly, is to do what's called flow charting your code, right? So I'm going to show you what flow charting is. It's really pretty simple. It's just a graphical way of depicting your code. If it helps you think about designing your code, I recommend you use it. I don't insist that everyone's going to use it. But the standard way is you have basically you draw a box that says do, and you do things in the boxes, and you have a sequence of boxes that look like this. It's really kind of straightforward. And so, for example, this might be, I can't think of one of our methods for this. It doesn't really matter. So, you know, this might be add flour. I'm going to go back to the pancakes. Add milk. Add eggs, right? So each step is in a box and you just join those boxes, and traditionally you go down the page joining boxes. Okay, simple, boring so far. The useful thing is when you start to get more complicated flow than just going straight down the page like that. So you start, the other kind of box that you'll find in a flow chart quite often is a diamond box, which is a test, which for example in this case says, is balance greater than or equal to price? Okay, and then you have normally you have two exits from a diamond box, one marked yes and one marked no. And if you go, and then this is where you branch your code, and if it's yes, the balance is greater than the price, then what we do here is say balance, or actually let's write this in English rather than in code. So subtract price from balance, and then we're going to go up here. Issue ticket, and then we're going to go here and return. We're done. Okay, if the answer is no, then we print an error and return, right? And that's a rather messy one because I don't have much space on the board. But if you do this process, I mean, for something that simple, it's quite obvious. But if you start building up more complicated methods, sometimes it's useful to visualize these things by drawing things at this level. It also means that you can talk about it, rather than writing this as code, you write the individual boxes can be things that you can talk about at a more of a high level. And then once you've done this design, you can start turning it into code. So it's basically useful, while you're getting used to expressing yourself in code, it's useful to think out a design first, and what you want the code to do, and then try to translate it into code. And so this is one way to try to write sort of visualize what you want your program to do before you go and try and write code in order to do it. So it's always a good idea to actually know what you want to say before you try to say it, essentially, is what I'm trying to get at here. And so if it's easier for you to start thinking at this high level first, I encourage you to do a design at that level. And we'll get into more complicated cases of this when we sort of deal with loops in a little bit of time. How are we going? Good. Okay, so I said this thing in the parenthesis is a condition that we want to test to see whether it's true or false. And if you remember in the first week we talked about variables, and someone asked me about booleans, which came up there. This is where you start using booleans quite a bit. A boolean is a data type that represents either true or false. So we've said that we already encountered strings which represent text and integers which represent numbers. Now we've just got a data type that there are only two values it can be. It can either be true or it can be false. And in fact the values are the word true or the word false. It has no other value that it can take. These are useful as flags and ways of testing things in our code. And so we can create a Boolean variable in the same way as we can create any other variable. by giving it the type Boolean, a name, and then initializing it. In this case, we initialized it to true. We could just as easily initialize it to false. So the reason that we want Booleans is so that we can test things in our code. And so there are just like there are integer expressions for addition and subtraction and multiplication, there are Boolean expressions for calculating things like testing whether two variables are equal. So x equals y tests is true if those two variables are equal, and it's false if they're not. X not equal to, and that's an exclamation mark, equals, that says x is true if x is not equal to y, and false otherwise. Less than or equal to, obviously corresponding things for greater than and equal to. The important thing here is to note that we use this double equal sign for equality and a single equal sign for assignment. So if you're testing something, you'll use a double equal sign. If you're assigning something, if you're giving it a value, you'll use the single equal sign. It's easy to get them a bit confused, and especially, it's not so bad in Java, but if you go and program in other languages, messing them up can really stuff your code around. So remember, you should always use the double equal sign for equality. So to have a look at what this is, what kinds of things this allows you to do, let's go and have a look at the, where is the, how do we find the, oh, come on, E? Oh, wrong thing. That's not what we want. What we want is this. If we view the code pad, we can test, make that a bit bigger. So if we can say 1 equals 1, hello, it's died, that's cool. Okay, if we do that, we break it. That's nice. Okay, let's not do that then. Let's try that again. Start it all over again. If all this fails, turn it off and start again. Ah, there we go. Okay. So if we say if we ask the question, is 1 equal to 1, it says it's true. If we ask the question, if 1 is equal to 2, it says it's false. Right. If we ask the question, is 1 greater than 2, it says it's false. And so forth and so on. So all of these are Boolean expressions, and they result in a value that's either true or false. The other thing we'll find later is when we want to start combining Boolean expressions. If we say, is 1 equal to 1 and 2 equal to 2, which is kind of weird, and it says yes, they're both true. And so this double and is a way of saying and. If you have a look, if you've got the textbook and have a look in Appendix C of the textbook, it has a list of all the Boolean operators. Again, we'll cover more as we go, as we need them, but there are other ways of doing things with Booleans that we will want to use as we go programming. That's really all we wanted to say about Booleans. So a Boolean expression, so this condition has to be a Boolean expression. It has to be something that we can evaluate to either true or false. Alright, so the last thing that I showed you there was printing text. Now unfortunately printing text in Java is kind of, uses a bunch of stuff that you're not ready to learn about yet. So you're going to have to learn this as black magic, and later on I might tell you more about what this is actually doing. But in general, if you want to print out text, you can print text to the console. Would you please shut up? Yes, that's you. Hi. Thank you. If you print text to the console, this is one way of printing out, getting output from your program. It's the easiest way of getting output from your program. It's the most basic and ugly, and you won't want to use this in real programs mostly, but it's helpful, especially when you're debugging and when you're writing simple stuff. And all it is this system.out.println, and then so that's a method, and the thing that's in parentheses of the method is the parameter, and that parameter is what gets printed. And basically, you can print almost anything you want. So you can print a string like this, and it'll print out that string on the screen. You can print a variable, and it'll print the value of that variable in the best way that it can. Depending on what that variable is, it might print it in different kind of formats, but hopefully it'll mostly, for the time being, it'll mostly do what you expect. Later on, you'll find that printing some objects gives you data that you don't want. Because it doesn't, if you've got a complicated thing and you try to print it, Java doesn't necessarily know how to print it. But most things you can print out fairly easily. So if you wanted to print out a price, you'd say system.out.println price. If you wanted to print out any other kind of variable, you could do that. The other thing that I didn't write down here, but we used there, is the idea of concatenation, where I think I showed you that if you added two strings together, it just joined them together end to end. So that's what we're doing here, is we were taking the string destination and we're adding the string, the destination string, which we had back up here. So destination string is a parameter. We're concatenating them together. So we're joining those two strings together and then printing that out. If we wanted to, we can actually even do this. We can say system.out.println, and then we could go something like hash price, and we could concatenate the ticket price. Now this is kind of, if you think about it, this is kind of weird because we're adding together a string and an integer, because the price is an integer and that text is a string. Java does something clever at this point. It converts the integer into a string and then it concatenates them together. That's sort of black magic at the moment, and it's even black magic when you come across it later, come to think of it. But it's one of those nice things that Java does for you automatically, is that if you try to concatenate a string and something that's not a string together, Java will automatically turn the thing into a string. Of course, sometimes this will mess you around, but hopefully, most of the time it'll do what you want it to do. All right, so the last thing I want to say. We've got a bit more time. I'm going to plow ahead into something new. No, I'm going to end with this because that's probably don't want to go somewhere new. Last thing I wanted to say. Okay, so I mean, if you're making a program with a beautiful GUI, you won't be using print to print output text. Print really is just for more or less a programmer's tool rather than an actual UI tool for most of the sake. You're going to have to use much more advanced thing in order to display windows and graphics and nicely formatted text. The console really is there mostly for debugging, and debug printing is one of the important skills that you're going to need to learn in order to debug your program. So I showed you the debugger before, which allows you to step through your code and investigate what's going on at every time step. The problem with the debugger is if your program is long and runs for quite some time, you don't want to be sitting there pressing the button over and over and over and over and over and over and over to see the bit that you want to see. And sometimes you'll run the same method 100 times and it'll only fail once in that 100 times. And you don't want to run it 100 times and watch it and step through it 100 times in order to find that one occasion. So when you have when you want to debug a large program, one of the useful ways to do that is debug printing, which is essentially to use this println statement, use system.out.println to print out the important parts of your state as your program runs. And then later on, when your program is finished, you can go look at that printout, and it'll be hundreds of lines, but you can search through it and find the bit where it went wrong. And this is an unfortunate part of programming, is often you have a large program which runs for quite a long time, and only somewhere in the middle of the program does it fall over, and so you have to create a log which records everything that the program did, and then when you get to the middle of the program, you can, when it falls over, you can look through that log and find out what went wrong. So println is your friend in that situation because it allows you to log parts of your state as you're going along. So debug printing is a useful skill to learn. It's basically as your program is running, print out the important parts of the state of the program in order to be able to examine them later. Okay, I'm going to call that a day for today. Remember the assignment spec should be out later today and finished. Remember, if you're in Infosys, to talk to Claude about it, and if you're in COMP1400, talk to me about it, but talk to your tutors first because that's what they're there for. Thank you for coming. See you all Thursday.